We were completely wrong about the moon. For over 50 years, we treated it like a solved problem, a place we had visited, studied, and filed away. 12 astronauts walked on its surface between 1969 and 1972. They collected rocks, took photographs, planted flags in fine gray dust. They brought pieces of it back to Earth and handed them to scientists who measured, dated, and cataloged every gram. We decided we knew what the moon was. Dead. Quiet. Understood. On April 6, 2026, 4 astronauts discovered we understood nothing. Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen launched on April 1st aboard the most powerful rocket NASA has ever built. The Space Launch System had been in development for over a decade, engineered to carry human beings beyond low Earth orbit for the first time in more than half a century. Their mission, on paper, was straightforward: fly around the far side of the moon, the side that never faces Earth and that no human eye has ever seen up close from a crewed spacecraft. Take some photographs, conduct observations, and come home. A loop around the moon. Ambitious, but clean. A mission designed to rehearse something harder that would come later. At 4,600 miles above the surface, their spacecraft passed behind the moon, and every radio signal to Earth went dead. This was expected. The moon's bulk physically blocked all communication with mission control, a phenomenon engineers call the blackout zone. There was no technical malfunction, no emergency, just the simple geometry of a rock 2,000 miles wide, sitting between 4 human beings and everyone they had ever known. For 40 minutes, mission control couldn't reach them. They couldn't call home. 4 people floated alone, with a landscape stretched out beneath them that looked, by all early accounts, profoundly wrong. Not wrong in the way a broken instrument reads wrong. Wrong in a way that seemed to resist description entirely. Before the signal died, Victor Glover tried to describe what he was seeing. This is worth dwelling on. Glover is a Navy test pilot, a profession that selects specifically for people who stay calm under pressure and communicate clearly in conditions that would unravel most people. He spent 168 days aboard the International Space Station, floating above an Earth he could circle every 90 minutes, watching storms the size of continents spin slowly beneath him. He is trained, specifically and deliberately trained, to observe unusual things and report them with technical precision. That is the job. See something, name it, transmit the data. He couldn't find words. His exact transmission to Houston before the signal cut out contained one sentence. Humans probably haven't evolved to see this. Then silence. 40 minutes of it. What did 4 astronauts see on the dark side of the moon that reduced a trained Navy pilot to a single sentence about the limits of human perception? Before we start, I want to tell you something. A lot of strange things have been happening in space lately. So, subscribe to this channel right now, and I'll tell you even more secrets of space. And write in the comments below what you think about all of this. So look at the moon tonight. You're seeing the near side. The familiar face covered in dark plains we call Maria. Ancient lava that poured into massive craters and solidified billions of years ago, leaving behind those broad, dark patches you can trace with the naked eye. About 31% of the near side is this smooth volcanic rock, a testament to a period of intense geological activity that reshaped an entire hemisphere. The far side has almost none of it, less than 1%. Instead, the far side is just craters stacked on top of craters, on top of older craters, like something hit it over and over for 4 billion years and simply never stopped. The crust on the far side is 50 kilometers thicker than on the near side, a dramatic asymmetry that planetary scientists have wrestled with for decades. No one fully agrees on why. The leading explanations range from differences in how heat escaped the early moon to the gravitational influence of Earth itself, pulling ancient magma preferentially toward one face. But none of them fully close the case. Something happened to the moon that split it into 2 completely different worlds. One side, the one facing us, got flooded with lava from within. The other side, the one we never see from Earth, stayed frozen in time, battered, ancient, wrong in a way that is difficult to articulate but impossible to ignore once you start looking at the data. And in the southern hemisphere of that hidden face, there is a scar so massive it shouldn't exist. The South Pole Aitken Basin. It stretches 2,500 kilometers across. If you placed it on a map of the United States, it would swallow everything from Texas to Virginia whole, erasing cities, mountain ranges, and river systems beneath its rim. It plunges 13 kilometers deep into the lunar crust, and the mountains along its edges reach 8,500 meters high, comparable to the tallest peaks on Earth. But the sheer size is not the strange part. In 2019, scientists pointed gravity sensors at the basin and began mapping what lay beneath the surface. What they found was buried roughly 300 kilometers down, a mass anomaly, a dense concentration of material weighing approximately 2.18 quintillion kilograms. To put that number in terms you can almost hold in your mind, it is the rough equivalent of burying a pile of metal 5 times larger than the entire island of Hawaii somewhere beneath the lunar crust. The anomaly is heavy enough to measurably drag the basin floor downward by more than half a mile, warping the geometry of the rock above it like a stone pressing into soft clay. The leading theory is that the dense mass is the metallic core of whatever object punched that hole 4 billion years ago, an asteroid or protoplanet of staggering size, whose iron heart separated from the rest of the impactor on collision and sank into the moon's interior, still buried there today like a bullet fragment the body never managed to push out. It has been sitting there, undisturbed, for longer than complex life has existed on Earth. The Artemis II crew flew over the eastern edge of this basin, the first humans in history to see it with their own eyes, rather than through instruments and orbital imagery. What they reported back didn't entirely match what the models said should be there. Christina Cook was watching the craters, small, recent impacts glowing bright white against the ancient gray rock below. She described them as pinprick holes in a lampshade, light punching through darkness in tight, concentrated points. Fresh impacts on the moon excavate material from beneath the weathered surface layer, exposing cleaner, more reflective rock that blazes against the surrounding terrain. But it wasn't just the brightness that caught her attention, it was the pattern. These new craters were scattered across terrain that should have stopped meaningfully changing billions of years ago. The moon isn't supposed to be this active. Impacts happen, of course, but not at this rate, not with this frequency scattered across a region this ancient. Something is hitting the far side more than current models predict it should be, and no one yet has a fully satisfying answer for why. Victor Glover fixated on the terminator, the razor-thin line dividing sunlight from shadow as it swept across the lunar surface below. Along that boundary, where the sun hangs just at the horizon and light strikes the terrain at an almost impossibly shallow angle, shadows become so deep and so absolute that they look like holes cut straight through to the moon's core. He radioed down that it looked like black holes you could fall through to the center. He also noted something else, the way light bent around certain crater rims, refraction patterns that didn't make sense given what the surface composition should be. Like the rock wasn't behaving the way moon rock is supposed to behave. The angles were wrong. The way the light scattered off certain slopes and rim edges suggested a material property that standard lunar geology doesn't account for. And there was no simple explanation sitting in the textbooks. The crew photographed a feature called Reiner Gamma, a bright, swirling pattern on the surface that looks like someone dragged white paint across dark rock in long, curving arcs. It has no elevation. It's not a crater, not a volcanic deposit, not any kind of raised structure or geological formation. Just a flat optical marking sitting on the surface as if it were painted there, visible from space, defying easy categorization. And underneath it, there's a magnetic anomaly. The moon has no global magnetic field, hasn't had one for billions of years. The dynamo that once churned through its interior went quiet long ago. But scattered patches of magnetized rock persist in the crust, locked in place like fossils of a field that no longer exists, like ghosts of something that used to protect the surface from the constant bombardment of charged particles streaming off the sun. Reiner Gamma sits directly on top of one of these patches. No one knows if the magnetism is actively shielding the surface from solar wind, deflecting those particles and preserving the brightness of the regolith beneath, or if something else entirely is responsible for creating that vivid, swirling mark. The crew photographed it as they passed overhead. The images captured details at a resolution no orbital camera had managed before. Fine structure in the swirl that raises more questions than it answers. The crew also saw colors, shades of brown and green, subtle blue tints in certain regions that had no business being there by standard models. Colors that orbital cameras flatten out and compress into uniform gray, but that human eyes, trained by millions of years of evolution to distinguish the faintest differences in hue, can detect in real time. Those color shifts are not superficial. They reveal mineral composition, the chemical fingerprints of what the surface is actually made of, and how it got that way. They speak to the age of surface features, to the history of impacts and flows and exposure. Information that in several cases doesn't match our existing models of how the moon formed, differentiated, and gradually cooled over the first billion years of the solar system. But the colors weren't the deepest problem. In 2023, researchers detected heat on the far side, a region roughly 50 kilometers wide, registering 10 degrees Celsius warmer than everything surrounding it. A thermal anomaly sitting in the crust of a world that has no business generating excess heat. The moon should be frozen solid in any geologically meaningful sense. It's been geologically dead for billions of years. There's no active volcanism, no detectable internal heat source, no tectonic grinding or friction, or radioactive decay at a scale that should be producing a localized warm patch on the surface. Nothing that should be generating warmth in one specific spot. But something is. And then they found the reason. They found granite, a massive buried block of it, sitting beneath the lunar crust like an intruder from another kind of world entirely. And granite doesn't form on dead worlds. It requires water in the melt. It requires the slow, repeated cycling of magma through a differentiated crust, processes associated with plate tectonics. The moon has neither, has never had either, as far as every model of lunar formation has insisted for decades. The scientists' best current explanation is that it's a volcanic remnant from roughly 3.5 billion years ago. A body of magma that intruded into the crust, was insulated by the rock above it, and never fully transferred all of its heat to the surrounding material. Still radiating warmth after all this time, like an ember buried under ash. Which means something under the moon's surface hasn't gone cold yet. And if one such remnant exists, the question becomes unavoidable. What else is still warm down there, and in how many places? Radar scans reveal something else layered beneath the surface. Underground tunnels, lava tubes formed by ancient flows, where the outer shell of a river of magma solidified, while the molten rock inside drained away, leaving hollow corridors behind. Entrance pits are visible from orbit, places where the roof has collapsed and opened a window straight down into the dark. Caverns potentially large enough to hold entire city blocks, entire buildings, entire habitats for future crews who would need protection from radiation and micrometeorite impacts. No one knows how big they truly are, how deep they extend, what conditions exist inside them. There could be trapped gases preserved from the early moon's interior, pristine volcanic deposits untouched by 4 billion years of surface weathering, temperature conditions dramatically more stable than the brutal swings between lunar day and night above. Right now, it's all speculation built on radar returns and surface pits. Future missions may eventually descend into them. For now, they remain sealed off, buried under billions of years of accumulated dust and silence. And then the crew saw the eclipse. As Orion swung behind the moon on its transit, the sun disappeared completely. A total eclipse as seen from lunar orbit, a geometry impossible from Earth's surface. It lasted 54 minutes, far longer than the fleeting minutes of totality any ground observer ever experiences. The sun's corona blazed out in a complete halo around the entire circumference of the moon, a burning ring of plasma extending millions of kilometers into space, suddenly visible in full because the blinding disk at its center had been blocked. Jeremy Hansen reported that the coronal light was illuminating the entire perimeter of the lunar surface simultaneously, highlighting terrain features along the edge, with a quality of illumination that simply does not exist at any other moment. Ridges and peaks stood silhouetted against burning white light, mountains that had never been photographed from this angle, with this particular geometry of light, throwing their true profiles into sharp relief for the first time. And during that eclipse, both Hansen and Reed Wiseman saw something else entirely. Flashes, brief bursts of light on the surface below, appearing and vanishing in an instant. They reported it to Mission Control immediately, and the science team came alive with questions. How long did the flashes last? Where exactly on the surface were they located? Could the crew reproduce the observation? Both astronauts confirmed seeing at least one flash, possibly more. The duration was too brief to measure with any precision, a fraction of a second each time, gone before the eye could fully register what it had caught. The explanation Mission Control offered was this. They were seeing impact flashes from meteorites, striking the far side in real time. The moon has no atmosphere to burn incoming fragments into harmless streaks of light. Whatever arrives hits the surface directly, and the kinetic energy of that impact releases in a sudden bloom of heat and light visible from orbit. No magnetic field, nothing between its surface and space. Every rock, every particle of radiation hits the far side with nothing to slow it down, nothing to deflect it, nothing to absorb the impact before it reaches the ground. For centuries, people on Earth have reported seeing flashes on the moon. Transient lunar phenomena, brief lights that appear and vanish before anyone can photograph them, gone in seconds, sometimes fractions of a second, leaving behind only the uncertain memory of an observer who can't quite be sure of what they saw. Astronomers have debated for generations whether they're real or optical illusions, a trick of atmosphere or fatigue or wishful thinking. Some are now confirmed meteorite impacts, the lunar surface recording a strike in a brief burst of light. Others might be electrostatic dust plumes thrown up by the interaction between solar wind and the surface, or outgassing from the interior, ancient volatiles escaping through fractures that reach deep into the moon's crust. No one knows for sure, and the absence of certainty has made the phenomenon easier to dismiss. The Artemis II crew may have just witnessed one, or several, during an eclipse that gave them a view no human has ever had, from the far side, looking back across a surface bathed in a light that no Earth-based telescope can reach. But they couldn't verify it. The flashes came and went too fast. The moment passed, the eclipse ended, and they moved on. What is hitting the far side? And why is it hitting more frequently than our models predict? Whatever is striking that surface is also striking the crew. Apollo astronauts reported seeing light streaks behind closed eyelids, even in total darkness with their eyes shut. High-energy particles punching straight through the hull of the spacecraft and through their retinas, leaving a signature the brain interpreted as light. Some of those astronauts developed cataracts in later life, a consequence scientists believe is directly linked to radiation exposure in deep space. Most lived long lives with no obvious cancers, which is reassuring until you stop and consider that only 24 people in all of human history have ever left the protection of Earth's magnetic field. That is not a sample size that tells you very much. The Artemis II crew is spending 10 days in deep space during solar maximum, the peak of the sun's 11-year activity cycle, and the period when radiation risk reaches its highest point. During solar maximum, the sun produces more frequent and more powerful eruptions, hurling charged particles outward at enormous speeds. A severe solar storm can deliver near-lethal radiation doses in a matter of hours. The Orion capsule carries significantly better shielding than anything the Apollo program could provide, with designated shelter areas designed to reduce exposure during an event. But cosmic rays are a different problem entirely. These are particles accelerated by supernova explosions in distant parts of the galaxy, traveling at nearly the speed of light, carrying so much energy that they penetrate almost any material we know how to build. No practical amount of shielding stops them completely. Researchers working on the problem of human deep space exploration describe radiation not as one concern among many, but as the number one limitation, the showstopper that must be solved before long-duration missions become truly viable. If a major solar event had struck during that 40-minute communications blackout, mission control would not have known until the signal returned. The crew had protocols. They had pressurized suits and oxygen systems, and procedures rehearsed until they were instinct. But none of that changes the fundamental nature of what those 40 minutes were. 4 people in a capsule roughly the size of a van, separated from every other human being by 2,160 miles of solid rock, bathed in a radiation environment the human body never evolved to survive, doing something that has never been done before in the history of our species. When the signal came back, mission control erupted. The crew had watched Earth disappear behind the lunar horizon, a pale blue crescent sinking slowly behind gray rock until it was gone entirely. Christina Cook described how seeing Earth from that perspective reminded her how fragile everything is, how much we take for granted when we stand on the surface of a planet surrounded by a magnetic field and an atmosphere that silently absorbs punishment we never see. But the Artemis II crew weren't the only ones who had turned their attention to the far side. China landed there in 2019. Chang'e 4 touched down inside Von Karman crater, a vast, ancient impact basin near the lunar South Pole, completing the first soft landing on the hidden hemisphere in human history. The mission required engineering solutions that no one had attempted before, including a relay satellite parked in a stable orbit beyond the moon, just to maintain communication with the lander. You cannot radio Earth directly from the far side, under any circumstances. The moon blocks the signal completely. There is no workaround. You either have a relay or you have silence. The rover that accompanied Chang'e 4 found minerals from the lunar mantle, olivine and pyroxene, material from hundreds of kilometers below the surface that had been blasted upward and outward by the colossal impact that created the South Pole Aitken Basin billions of years ago. It was a window into the moon's interior that no sample from the near side could provide. But that turned out to be only the beginning. In 2024, China's Chang'e 6 mission went further still. It collected physical samples from the far side and brought them back to Earth, the first time material from that hidden hemisphere had ever been returned for laboratory analysis. Scientists could now hold the far side in their hands. Those samples are still being analyzed, the full results not yet published. But what researchers are saying in private conversations and at conferences is already forcing a serious reconsideration of fundamental assumptions about how the moon formed and evolved. The isotope ratios are wrong. The mineral structures don't match what current models say should be present, given what we know about lunar formation. There are elements present in concentrations that simply shouldn't exist if the standard story is correct. Something about the far side's formation history is not just different from the near side in the way that one side of a mountain differs from the other. It appears to be different in a deeper, more structural sense, as though the two hemispheres formed under genuinely different conditions, or at different times, or were shaped by forces and events that our models haven't accounted for. Like the moon isn't quite the single unified object we assumed it was, and no one can yet explain why. China has already announced plans for future far-side missions, longer duration landers, sample return from multiple sites, eventually a crewed mission. They're not just exploring, they're claiming territory, scientific territory for now, but the implications reach further than any single experiment or rover traverse. The far side represents a strategic foothold unlike anything else in the inner solar system, and China understands that better than most. And the far side offers something else, something no other place in the solar system can provide: complete radio silence. The far side is permanently shielded from every electromagnetic signal on Earth, every cell tower, every broadcast, every Wi-Fi router, every radar ping and satellite downlink, an accidental emission from 7 billion humans living their electrically noisy lives. All of it blocked by 3,400 kilometers of solid rock, an impenetrable wall of lunar geology that has been filtering the cosmos in quiet for 4.5 billion years. For radio astronomers, it's the quietest listening post imaginable, the kind of silence that scientists on Earth can only dream about, even in the most remote corners of the planet. Telescopes placed there could detect frequencies that Earth's ionosphere absorbs and scatters before they ever reach our instruments. Frequencies from the early universe, signals from the cosmic dawn, the era when the first stars ignited and hydrogen began to sing at 21 centimeters. We have never been able to hear that signal clearly. From the far side, we might. Multiple agencies have drawn up plans to build observatories there. NASA has studied lunar radio telescope concepts for decades. China has flagged it as a scientific priority. The moon isn't just hiding secrets from us. It's offering us a way to hear the universe more clearly than ever before. But first, we have to figure out what the moon actually is, because it turns out we don't know nearly as well as we thought. We landed on the moon 6 times. We collected rocks from a handful of sites spread across a relatively narrow band of equatorial near-side terrain. We brought back about 382 kilograms of material and declared ourselves experts on a world with a surface area larger than Africa and Asia combined. We built models of the entire moon based on that local data, on those 6 small patches of ground. That's like landing in the Sahara and declaring Earth is made of sand. The far side is where the real story is, a landscape so ancient and so battered that it records impact events the near side erased long ago, buried under flows of dark volcanic basalt. A basin so enormous, it may have actually tilted the moon on its axis in the early solar system, repositioning its entire geography. A metallic mass buried so deep beneath the surface that it warps local gravity in ways our orbital measurements are still trying to fully characterize. Heat sources that shouldn't exist at this stage of the moon's thermal evolution. Sealed lava tunnels kilometers wide that no human or robot has ever entered. A crust so thick on the far side that it fundamentally breaks our models of how a moon this size should have cooled after formation. Astronaut Victor Glover said something after the crew cleared the far side during the Artemis 2 flyby. Something simple and quiet. The moon isn't just a poster in the sky, it's a real place. He's right, and the more we learn, the less comfortable that realization becomes. The granite that shouldn't be there, forming in conditions that require a heat source we can't account for. The mass that doesn't fit any clean geological explanation. The heat that won't fade in a world that should have gone cold billions of years ago. Magnetic ghosts preserved in a crust that lost its global magnetic field long before the dinosaurs existed. Moonquakes that Apollo seismometers detected decades ago, suggesting that something still moves and shifts inside a world we confidently called dead. Every answer the far side offers seems to open 3 more questions, each one stranger than the last. The Artemis 2 crew splashed down in the Pacific on April 10th. They brought back thousands of photographs taken during the lunar flyby, images captured from perspectives and distances no human had experienced since the Apollo era. Most of those images haven't been released yet. The full image set is still being processed, calibrated, and cataloged by the teams at Johnson Space Center. Those images are going to matter enormously. They'll capture terrain features that no camera has resolved at this angle or resolution, shadow patterns that reveal subtle topography, surface textures that hint at composition and geological history. Details fine enough to help mission planners decide where future landers touch down and where future astronauts walk. The crew also named 2 craters during the flyby, an informal tradition with deep roots in spaceflight history. One they called Integrity, after the nickname the crew had given to their Orion spacecraft. The other they named Carol, after Reed Wiseman's late wife who died in 2020. It sits on the boundary between the near and far sides, a bright spot visible from Earth if you know exactly where to look, a quiet landmark perched on the edge of the unknown. And when future missions go down, when astronauts step onto the far side surface for the first time in human history, they are going to have to answer questions that should not need asking about a dead world. Questions that, by every model we built over the last century, should have already been answered. Because the moon was supposed to be simple, geologically inert, a cold, airless relic, a place that finished its story 4 billion years ago and has been silent ever since. Except it has not been silent, not even close. Why is there heat where everything should be frozen? Residual thermal signatures rising from depths that have no business still being warm. Why are there magnetic fields locked into a crust that lost its global magnetism billions of years ago? Fields that cluster in strange patterns and point in directions that contradict the impact history we thought we understood. What is inside those sealed lava tubes that radar signals can partially map but never fully penetrate? Those vast underground corridors stretching for hundreds of kilometers beneath the surface, dark and pressurized and untouched. What is the metallic mass buried approximately 300 kilometers below the South Pole Aitken Basin? It is one of the largest and oldest impact craters in the entire solar system, and something enormous is sitting beneath it, dense enough to warp local gravity in ways that do not match any impact model we have ever run. It is not supposed to be there. Nothing in our understanding of how moons form and evolve explains it being there. Why are the isotope ratios and far-side samples measurably different from near-side samples if they both came from the same moon, formed in the same event, out of the same material? That should not be possible. And yet the chemistry disagrees with the origin story. What is hitting the far side more frequently than our impact models predict? Something is striking that hemisphere at a rate that does not line up with the distribution we expect from the known debris fields in the inner solar system. And what exactly did Victor Glover see that made him say humans have not evolved to process it? Because Victor Glover is not someone who uses words carelessly. He is a Navy captain, a test pilot, a man who has spent 168 days living and working in the vacuum of space. Someone professionally trained to observe, to stay calm, to describe what is in front of him with precision. And what he said was that what he was looking at was beyond what humans evolved to see. Not strange, not surprising. Beyond the capacity of human perception to properly receive. The moon is not what we thought it was. It is older and stranger and more internally complex than the story we told ourselves for decades. And the far side, the hemisphere that has faced away from us for the entirety of human existence, has barely been touched. We are only now beginning to find out what it is actually hiding. That's all for today. If you like space stories and want to stay up to date with new episodes, subscribe to this channel and turn on notifications. See you in the next podcast.